Hi everyone, my name is Xingwen, and I worked with Yuying and Harold together on exploring the realization of tonal patterns in spontaneous speech. First of all, let me give you some idea of tones in Mandarin. We all know that Mandarin is a tone language. Well, what does it mean to be a tone language? It means that the same consonant-vowel combinations can express different meanings when given different tones. For example, if you take the two syllables qi shi and keep the following tone for the second syllable, by changing just the tone of the first syllable, you get at least 4 different meanings. The light blue lines represent how each of the 4 lexical tones would look like in textbooks. For this presentation, we limit ourselves to only one tonal pattern, the rise-fall pattern. Phoneticians have studied Mandarin tones using lab speech. The figure on the right-hand side is taken from a study of contextual tonal variations in Mandarin. These lines are F0 contours. I traced the rise-fall pattern using red. Unlike what the textbook has told us, the rising tone is not realized as plain rising in the first syllable. Instead, there is an initial falling before the rising starts. As a result, the shape of the rising tone resembles the dipping tone in the textbook. Now that we've seen the canonical pitch contour for the rise-fall pattern, what about spontaneous speech? Let's just take one word 学校 meaning school as an example and look at the spectrograms of the dictionary pronunciations first. We took the pronunciations from 2 online dictionaries, one from Beijing and one from Taiwan. The dictionary forms are produced in isolation. This is the Beijing Mandarin.
学校
From the spectrogram, you can see a very beautiful dip and rise in the first syllable and a straight fall in the second syllable. This one is from Taiwan.
学校
Here the dip is much shallower, but it is still visible. If you interpolate over the voiceless consonant areas in these dictionary forms, you get a pitch contour very close to what people find in lab speech. And what about spontaneous speech? What do people really say in conversations? We're going to show you 3 instances of the word school from the same speaker from our spontaneous speech corpus. This is the first one.
学校
And the second one.
学校
It appears that the intervocalic consonant has already disappeared, and these speech contours seem very flat. And the last one.
学
It sounds like one syllable already. Although produced by the same person, the words school sounded very different to each other, not to mention the deviation from the dictionary forms. You can also see the differences in the duration of each token. The duration of the dictionary forms are at least twice the duration of the word produced in spontaneous speech. And what would be the factors behind such varying tone contours? And can we try to model the rise-fall pattern in spontaneous speech? This leads to our own investigation. The data we have here is extracted from the Taiwan Mandarin corpus. It's a spontaneous speech corpus collected from interviews with 55 Taiwanese Mandarin speakers. Both female and male participants are interviewed. After data processing and outlier removal, we obtained a clean dataset for the rise-fall tonal pattern with 290 distinct word types, where 85% of them occurred only once in the corpus. However, these hapexes account for only about 10% of the tokens we had. They are treated as one big group in the following analysis. We then fitted a generalized additive mix model to model F0 as a function of normalized time, word frequency, local speech rate, gender, and tonal context. What we found first was the effect of gender on the realization of tonal contours. We first took the Taiwan Mandarin corpus and obtained one predicted pitch contour for each gender. As expected, the mean pitch height is different for female and male. And if you look closer to the amount of pitch change they go through, you'll notice the range of pitch change is much greater for female than for male speakers. The male speakers produce little variation in pitch when they say words with rise-fall pattern. We replicated our findings in another spontaneous speech corpus from Beijing. The gender difference is observed across two distinct variants of Mandarin. This time, the predicted pitch contour for male speakers is almost indistinguishable from the predicted mean. Then we look at word frequency. We fixed the local speech rate and plotted the model predictions at different word frequencies. Here you can also observe the gender difference. There's just much more going on in the female panel than the male one. If we first look at the panel for female speakers, we still see the general fall-rise-fall pattern across all word frequencies. If we take a closer look, the pitch contour of the highest word frequency stands out immediately as much flatter than the other lines. Its dip and peak are both less pronounced, and the positions at which they occur is also fronted, while the peaks and valleys of other lines stay roughly in the same region. If we look at the dip in the first syllable, it seems that the higher the word frequency, the shallower and earlier the dip becomes, with the exception of the line for all the apexes. There isn't much difference in the position and height of the peak in the second syllable. If we look at the panel for male speakers, there is very limited variations in pitch, but we can still see that the line for the highest frequency is different from all other lines. It has completely lost the initial dip, and its peak is also lower and occurs earlier, close to the syllable boundary. We found from our model that every word type is given a particular pitch contour. Here you see 9 of them. In the figure you see 2 curves for each word type, color-coded by gender. When put together in a plot like this, you see more variability in the red curves for female speakers. This is because the females and males are put under the same scale. The fall-rise-fall is still obvious to the eye across different word types, but the shapes of the pitch contours are different. While some may have quite similar general shapes, you'll find their pitch height or positions of peaks and valleys to be different. This characterizes a word-specific pitch contour, which could be seen as a signature of the word. This is potentially beneficial to the listener as the words are more distinguishable from each other. To summarize, the rise-fall pattern in spontaneous speech is generally realized as fall-rise-fall, and there are a lot of things that together influence the pitch contours we see. First of all, in spontaneous speech, female speakers appear to produce their tones more saliently than the male speakers. Then, higher frequency words have less pronounced tonal contours, which is visually simpler and flatter. For both male and female speakers, we found that the highest frequency words have earlier peaks, as if they are getting their own forms, like irregular verbs in English. This fronted peak is an irregularity, which could be an advantage for discrimination. And we also found word-specific realizations of the tonal patterns in spontaneous speech. So, what are the implications of our study? First, we found that GAMS and spontaneous speech corpora together give us a more powerful tool. Owing to them, this pilot study into tones in spontaneous Mandarin revealed that across two distinct variants of Mandarin, when compared with female speakers, male speakers have less dynamic pitch contours, whereas when put under lab speech conditions, such differences may be less noticeable because the speakers may, without themselves knowing, speak their language with a more formal register. Moreover, we found that tone contours are also co-determined by word frequency. Higher frequency words tend to have shallower pitch contours. To investigate the effect of word frequency and word-specific tone realizations, We need large corpora and the controlling of many other factors. This is where game and spontaneous speech corpora come in handy. We also found that words frequency appear to be a lexical effect. This suggests that tone contours are also caught up in this trade-off between maximizing discriminability and at the same time keeping generalization still possible. And the word-specific tone variations that we see could be a result of such an equilibrium. This brings me to the end of my presentation. Thank you for your attention.